talk about number 3, and then we'll see, then we'll look at 5, let's see what comes up. Okay, so the idea here is that you've got a grid, and this grid represents an experiment, where IV1 is A, IV2 is B, and you have to figure out how many subjects you need for the experiment, depending on what kind of experiment you're running. And all you know is that you need to run 20 subjects in this condition. You have to have 20 subjects in each condition. And you know that you have these 3 different kinds of designs potentially. So let's think about this. So the first kind of design you have to figure this out for is a random groups factorial design. What do you know about random groups factorial designs? They're all between, right? If you go look at your flowchart of doom, right, you see random groups factorial design over here. You have all manipulated variables. They're all between subjects variables, right? You know these things about this. Okay? So that means that A is between subjects and B is between subjects. Right? What do you know about between subjects variables? What does it mean for an independent variable to be between subjects? What's that mean?
They're not doing the same thing.
Huh?
They're not doing the same.
Who's not doing the same thing? Which groups? So, for example, if A is a between subjects variable, what does that mean? It means that the people who do A1 are different than the people who do A2, right? Does that make sense? Okay. So if there are 20 people here doing A1, I have to have 20 people per condition. I can't use them again because it's between subjects, right? So I need 20 new people here. Because this is between subjects. So if I have to have 20 people in each condition, well, I've got 20 people here. I need 20 people there because I have to have 20 people in each condition. And I can't use the same people again because it's between subjects. Now, if B is between subjects, that means different people do B1, then do B2, then do B3, right? 3 different levels. I have to have different people for every level of that IV2. So this group right here is A1, B1. It means that it counts as an A1 group and it counts as a B1 group too. So if I've got 20 people here in B1, and this is a between subjects variable, I can't use them again because the people who experience B1 can't do B2. And they can't do B3. They have to just in B1, which means I have to have 20 more people here. And because these are all between subjects, I can't have the same people do A1 as do A2, so I've got to have 20 in every box. So 20 plus 20 plus 20 plus 20 plus 20 plus 20. What's the answer? How many people do I need for this experiment if it's a random groups design? 120. That's if it's random groups. Because they're both between subjects. So let's look at the next one. Okay, this one says, the next one is a complete repeated measures factorial. What do you know about that? What do you know about a complete repeated measures factorial? Well, so what the complete part means what? The complete part means what? The repeated measures part means what? Got music going in the room? So we can celebrate while we do math. What does complete mean?
Each group experienced like each condition more than one time.
Okay, so they experience each condition more than one time. What's repeated measures mean?
Within the subject.
What's within subjects? Which variables?
Both of them.
Both of them. Okay, so a complete repeated measures factorial is an experiment that has independent variables that are all within subjects, and the subjects experience each condition more than once. Okay. Well, what's really important here is that this is within, and this is within. Okay. Well, we're going to be celebrating all class period, I can tell, with the music next door. All right. So this is within and this is within. I got 20 subjects right here. So if A is a within subjects variable, can the people who experience A1 also experience A2? Yeah, because it's within subjects. That means that it's the same subjects again. So I don't need new subjects. They can just do both. B is a within subjects variable. What does that mean? Means that these 20 subjects, the people who do B1, also do B2, and they also do B3, because it's within subjects, right? Same subjects. And A is within subjects, that means whoever does this also does that. Right? Within subjects. So if this is all repeated measures, then, and it's 20. Gathering data from 20 subjects in every condition, just this time it's the same 20 in every condition. They have to give me data in all 6 conditions because there's 2 independent variables. One has 2 levels, one has 3. That means there are 6 different conditions and every subject has to give me data in every one. So I only need 20 subjects because I can reuse them. They're recyclable. All right. Now let's see if you get it. Last one says we're going to do what? A mixed factorial design. What's a mixed factorial design?
One of the variables is between subjects and one of them is within.
Okay, so one's between and one's within. It also says there are 2 answers. Give them both. How are there 2 answers?
Because you don't know which one is between and within.
You don't know which one is between and which one is within, do you? So we've got 2 situations here. Two possible situations. Okay, we've got 2 possible situations. We know we've got 20 in the first box. Okay, so mixed means one of the subjects is between and one of them is within. All right, well let's do it this one first. Let's say that this is between and this is within. Okay, what does that mean? So if this is between, this one's between, what goes here? 20 or an arrow? Why?
Because you have to have a different group of participants for that condition.
You have to have different people doing A1 as are doing A2, because you have to have 2 different groups, because this is a between subjects variable. Now, B is a within subjects variable. So what goes here? 20 or an arrow?
Arrow.
What goes here? 20 or an arrow? What goes here? 20 or an arrow? What goes here? 20 or an arrow? Right, because B is within subjects, it means whoever does B1 can also do B2 and do B3. So if it's set up like this, N is 40. Because I need 20 subjects for each level of the between subjects IB, but then I can reuse them over and over for the within subjects IB. The other possibility is that this one is between, the B variable is between, and the A variable is within. It's the other possibility. So what goes here? Error. Right, because the same 20 subjects that can do this condition can do this one. So just an arrow. Okay. What goes here? 20 or an arrow? 20. Because this is between subjects, so I have to have different subjects for every group. So here, n is 60. So you need to be able to figure out from the description, like this is a P&E factorial, this is a whatever. You need to be able to figure out whether the variables are between subjects or within subjects. And then if I tell you how many subjects you have to run in every condition, you should be able to tell me how many you need for the study. This is just a practical application of knowing what it means to have a design of a different type. So notice that the random groups factorial takes the most subjects because you have to have different subjects in every single condition. Repeated measures takes the fewest because you can reuse all the subjects in every condition because you use them over and over and over. And then the mixed factorial is somewhere in between because it depends on which IV is between subjects and which is within. But you should always be able to figure out how many subjects you need to run, given the kind of study that you're doing. Does anybody have any questions about those? Does that make sense now? What you need to do? All right. What would you like to see next? Let me ask you, so for I'm curious how you guys did on number 1. You think you got it? Because 1, I mean, this is where you have to say what the IVs are, what the levels are, whether the IVs are between or within, manipulator subject, what the factorial notation is, and what the factorial design is. You think so? I think you should tell me what you got, and I should tell you if you're right. Okay, so let's take a look. Let's look at the first one. Because this is it, right? I mean, you have to be able to tell from the description what kind of study it is. So, it says, researchers temporarily influence participants' self-esteem by telling half of them that they did very well on an intelligence test, and half of them that they did very poorly. Researchers are so mean. Afterward, the participants in both self-esteem groups were asked to rate a videotaped speech given by a Confederate who did either a very good, okay, or poor job. Each participant saw only one version of the speech. Okay? So, what do we know about what are the independent variables here? I need 2 independent variables. Self-esteem, okay. Good. And what are the levels of self-esteem?
You did well.
So, how do you think you would feel if they said you did really well on an intelligence test?
Pretty good.
Okay. So, the self-esteem was good. And what if they told you you didn't do very well on the intelligence test? Bad. Something like that. Okay. Good and bad. Okay. Is self-esteem a between subjects or within subjects variable? How do you know? Well, I can feel good and feel bad. It just depends, right? I mean, like in the morning I might feel good, and then something bad might happen and I feel bad.
You're only told one.
That's right. The point here is that in here it says that half of them were told they did well and half were told that they didn't do well. So they're saying in the description that it was either one or the other. It's certainly possible someone can feel good right now and feel bad later, or feel bad now and feel good later, right? We don't always all feel exactly the same. So it's possible it could be within, but it's not in this case, because they say half and half. Okay, so it's between. Right? Is it a subject variable or a manipulated variable? It's manipulated. How do you know?
The researchers control the way they built math based on what they told you.
That's right. The researchers could randomly decide whether somebody was going to be told they did well or whether they did poorly. This is not the person's real, regular, everyday self-esteem. This is their manipulated self-esteem as a result of what the researchers told them. So this is a manipulated version. Okay, cool. So now we've done the first part where we said whether we've done up to the factorial notation in design. Let's get the other variable first, and then we'll finish that part. What's the other independent variable here?
The type of speech.
The type of speech, or the quality of the speech, right? The speech quality. Okay, and what are the levels?
Very good.
Okay.
Very good. Okay. Okay, so the Confederates watched, the participants watched the Confederate give a speech, and they either got to see the time when the Confederate gave a very good speech, the time when the Confederate gave an okay speech, or the time when the Confederate gave a poor speech, but they didn't see all three. They only saw one, right? It's the same person. It'd be really weird to watch somebody give the same speech 3 different ways and rate it. So they only got to see one. So what does that tell you about this variable? Is it between subjects or within subjects? Between, I have over between what? Because they only see one, that's right. And is it a manipulated variable or a subject variable? Why is it manipulated?
They're not choosing the conditions they get to see. They're not choosing the conditions of the speech that they get to see.
Who's not choosing?
The participants are.
True, the participants are, this is not some pre-existing condition for them, right? The researchers can randomly assign them to see one of the 3 speeches, right? So this is manipulated for that reason. The researchers have control over who sees what. All right, so what's the factorial notation here? 2 by 3. Now, if you happen to do it the other way around, where you did speech quality first and self-esteem second, that's also fine. Then you would just say it's a 3 by 2. Doesn't make any difference. 2 by 3 and 3 by 2 both have how many conditions? 6. So it makes no difference. So it's a 2 by 3. And then what do you know? Now we have to do the factorial design. So you have to look at your flow chart, and you have to say, okay, I've got all between subjects. The IVs are manipulated. The subjects were randomly assigned to the conditions. So what do I have? Random groups. Random groups factorial. Cool. All right, that was the easy one. Now your brain's warmed up. B. All right. Okay. So, participants were shown the results of 20 polygraph tests and asked to determine whether or not the person who provided the polygraph data was lying or telling the truth. A male Confederate produced half of the polygraphs. A female Confederate produced the other half. Each Confederate lied on half of the polygraphs and told the truth on the other half. All right. So I need some IVs. Again, there are 2. Somebody give me one of the IVs.
Sex of the Confederate.
Sex of the Confederate. Okay. And what are the levels of that? Male and female. Those are not the only possibilities for sex, but those are the 2 that were used here. Most common ones. Okay, male and female. All right. Is sex of the confederate a between subjects variable or within subjects variable? I hear between. Someone says within. All right. Smackdown. Fight it out. Who's right? Somebody is. Is it between or is it within? You're making a really weird face. You don't understand what?
How would it be?
You can't randomize. Like, that's what they have.
Okay, so let's read the description again. It says, participants were shown the results of 20 polygraph tests and asked to determine whether or not the person who provided the polygraph data was lying or telling the truth. A male confederate produced half of the polygraphs. A female confederate produced the other half. Each confederate lied on half of the polygraphs and told the truth on the other half. So if I ask you, is this, we're talking about what the subjects experience. Do the subjects experience polygraphs made by males and polygraphs made by females? Yes, because it says they were shown 20 polygraph tests. 10 of them were made by a man, 10 of them were made by a woman. So the subjects are experiencing both polygraphs made by the man and polygraphs made by the woman. This is a within subjects variable because they're experiencing both. Remember, we're not talking about the subject's sex. We're talking about the sex of the person who made the stimulus. And it doesn't make, we have no clue what the sex of the subjects are. We don't know if they're male or female, intersex, we have no clue. So all I can say is I do know that all of the subjects heard polygraphs made by a man and they heard polygraphs made by a woman. Because they heard 20. They looked at 20 polygraphs. Half were made by a man, half were made by a woman. So they had to get stimuli from both of these conditions. Make sense? That's why it's within. Is this a subject variable or a manipulative variable? Time for another smackdown. Some people saying subject, some people saying manipulative. Okay. Now remember, a subject variable. What's a subject variable about? The subjects. Is this about the subject's sex? This is about the confederate sex. This is not a subject variable. This has nothing to do. The subjects don't come in with the pre-existing condition of having polygraphs made by somebody else. The subjects can be randomly assigned to experience male, female, female, male, male, female, 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 male, 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 female, female, male, male, female, male. Right? I can randomly assign that, right? Because I can mix it up. They've got 20 polygraphs they have to look at. I can randomly assign which ones they see in whatever order I want. So this is manipulated. It's not a subject variable because it doesn't represent a pre-existing condition of the subjects. Subject variables are always about the subjects. We don't have any idea what the subject sex is. We don't know. No clue. All right, the second one. What's the other ID? Truthfulness. We'll go with that. Okay. And what are the levels of truthfulness? Truth, true or false. Okay. Because it says half of the polygraphs, the Confederate lied on half of the polygraphs and told the truth on the other half. So that means that there were 10 polygraphs made by a man and 10 polygraphs made by a woman. It also means that there were 10 polygraphs that the person told the truth and 10 polygraphs where the person told a lie. So think about what that means here. So we have truth, true or false. Over here we have sex. We have male and female. We have cases where there was a man who made the polygraph and he told the truth. where a man made the polygraph and told a lie. And there are cases where female made the polygraph and told the truth, or where a female made the polygraph and told a lie. Now, so if there's 20 stimuli across these 4 conditions, how many stimuli are there of each type then? 5. Okay, that's good to know. And the subjects saw all 20, right? It says they saw 20, so they had to see all of them. So did every subject see some that were true and some that were false? Yes. So what does that mean about this variable? Is it between or within? It's within too. And is it possible for the researchers to randomize the order in which they saw true or false? Yeah. You can totally randomize it. So this is also manipulated. All right. So we've got 2 within subjects variables that are manipulated. So now we have to figure out the notation and design type. So what's the notation? 2 by 2 is easy, right? We can do that. 2 by 2. All right, now the design type. How do I figure this out? I have to look at this flow chart, right? So I have all within subjects variables, and the question is, how often is each subject exposed to each condition? Once or more than once? More than once, right? Because each condition is exposed 5 times, right? So if it's more than once, what do I have? That one. 2 by 2, complete, repeated measures. Factorial. So the important thing to remember when you're identifying independent variables, you want to think carefully about, are the subjects experiencing just one level, or are they experiencing all of them? You have to be able to figure that out from the description. You want to find the words in the description that give you the clues you need. When you're trying to decide whether it's a manipulated variable or a subject variable, you have to think, is this an inherent quality of the subjects that they came into the study with, or is this something that the researchers can randomize? The researchers can randomize it, do random assignment, or randomize the order of presentation, then you're talking about a manipulated variable. If they can't, then it's probably a subject variable, unless it's time, in which case it's a freaky variable of its time. Okay, what about the last one? The last one. It says, a Georgia State researcher is investigating the extent to which drivers of different ages are distracted by different in-car activities. Oh, distracted by in-car activities? That would never happen. All right, an equal number of participants between the ages of 16 to 18, 36 to 38, and 56 to 58 are placed in a driving simulator and asked to engage in a randomly ordered sequence of 4 activities. Talking to a passenger in the car, talking on a cell phone, texting, or listening to the radio. The researcher records the number of, I should say of, like I'm glad I can type, of attention-related errors they make. For example, missing a traffic sign or signal, failing to notice important changes in the behavior of other cars. In each distraction condition, each participant experiences each distraction condition 1 time. All right, hit me. ID1. Age. What are the levels of age? 16 to 18. That terrifying age for the parents of the drivers. Let me tell you, my daughter's 15, turning 15 soon. All she can think about is when that 15 and a half rolls around. Permit! I'm like, yeah, not my car. I don't know what you think you're going to drive, but all right. And then 36 to 38. My daughter would put it old. And then 56 to 58, or as my daughter would put it, practically dead. Okay, she's 14. 56 to 58 seems really, and then I'm like, well, you know, Nana and Pappy are like 80. She's like, I know. And they're still alive. I'm like, what's amazing is that they were my parents and they're still alive. I'm surprised it didn't kill them already. All right. I was a bit of work. Just a little work. All right. Next. What's the other IB?
Car.
Hmm?
Car activity.
The car activity. Or the type of distraction, maybe? Either of those would work. Okay, and what are the levels?
4.
The levels are 4, okay? What are they?
Okay.
Talking with a passenger. We've all done that. Okay? Texting. We've never done that. Ever. Okay? Next. Talking on a cell phone. Okay? And listening to the radio. I always do that. Okay, so age. Is that a between subjects variable or within subjects variable? In this case. Because certainly everybody can. I mean, I was 16 at some point. I was 36 at some point, and at some point I hope that I will eventually become 56. Not there yet, despite what my daughter thinks. What do you think? We have a vote for between. Why between? Because they're only one age at the time of the study, right? This is not a longitudinal study. They're just getting people all come in at the same time. So this is between. Okay. All right. And is it a subject variable or a manipulated variable? It's a subject variable, right? This absolutely represents a pre-existing state, right? The subjects were selected because they were the right age. The researchers could not randomly assign them to their age. Hey, today you're 18. Researchers had the power to do that, we would make a lot more money. Hey, guess what? You're 20 again. Bing! Okay. All right, distraction condition. What do we know about this condition? It says they're asked to engage in a randomly ordered sequence of 4 activities. Each participant experiences each distraction condition one time. So what do I know about this? This is within subjects, because every participant is doing all 4, but in a randomly ordered sequence. Okay? And is this a subject variable or a manipulated variable? It's manipulated. It says it's a randomly ordered sequence, right? So if it can be randomly ordered, it must be manipulated. Okay, whew, this is complicated. We've got a between subject variable and a within subject manipulated variable. What do I have? What's the notation?
3 by 4.
3 by 4. Okay. 3 by 4. All right. 3 by 4 what? 3 by 4, we have a vote. This is a 1 between and 1 within. Okay, means you got to go to chart 2. Flip over. Chart 2. And then I have 1 manipulated and 1 subject variable. Is the within subjects variable time? No. So I have a P and E factorial design. You will not get this handout for your test. It's a good thing to put a little adorable mini version of it on your note card. But don't make it so small you can't follow the arrows. I've had students go, I can't read what I wrote. I'm like, so come up with a good way to make this mini for your note card if you can't remember everything that's on it. Okay, we have a 3 by 4 P and E factorial design. All right. All right, votes for the next thing. That make more sense now? And how do we know? So we've got everything on there. All right, next question.
7.
7. All right, we've done 3, we've done 1, and now we're going to do 7. Okay, 7.
Yeah, there's some doesn't exist.
Oh, never mind.
I'm like, maybe 6?
Yeah.
6, I can do something without like 1. Maybe it got numbered weird on your computer. Is this the one you want to do? I guess the more critical question, is that the one you want to talk about?
Yeah.
That one? The one with the 6? Okay, just check. 7! And you got it all right! 7 was perfect. Okay. All right, so here's our challenge. We've got this source table, okay? And then you've got to figure out all this stuff about it, right? So this is basically showing me that you can read the table and pull out all the important pieces. So this is kind of using stuff you learned for the last exam for the new thing, okay? So this is a different application of the stuff you learned before. Okay, so everybody has this in front of them so they can see where, because I have to, okay. All right, so the first thing we got to figure out is degrees of freedom. We're doing this all for IV1, right? Okay, so for IV1, I need to know, let's see if this way I can check. IV1, I need to know degrees of freedom numerator. So here's IV1. So what degrees of freedom would I use for the numerator? This one, right? 1. Okay. What would the degrees of freedom denominator be?
Within conditions.
Would be 24. Yeah, 24. All right? Then, if I'm going to get F critical, I'm going to go look at the F critical table, right? Under, with 1 as the numerator, 24 is the denominator, and there's no other information, so we assume alpha is 0.05. So what do you get? 4.26? Yes? All right, we have consensus.
This one.
All right. Now what about F observed? How would I calculate F observed for that variable? What's the formula?
MS
Okay, it's going to be, so F observed for IV1, okay, it's going to be mean square what? For IV1 over mean square within conditions. Okay, so what's my mean square for IV1? 120. What's my mean square within conditions? 5. So what's my observed? 24? Is that what you got? Huh? Yep. Okay. See, you got this. Okay, now we got it. It says we want to do eta squared, right? The partial eta for this one. What's the eta squared for IV1? How am I going to do that? What's the formula? Sum of squares, what? For IV1 over sum of squares for IV1 plus sum of squares within conditions. Okay, so my sum of squares for IV1 is 120. So that's 120 plus, and then my sum of squares is also 120. So that's 120 over 240, which is what? 0.5 or 50%. Cool. Okay. Now, with all that information, I can actually write out an AP-style statistical statement, right? How do I do AP-style statistical statement for ANOVA? It's going to be F, parentheses, 1, comma, 24, right? The two things I figured out at the beginning. Equals, then what? 24, I put my F observed, then what? P is less than 0.05. What's next? Eta squared equals 0.5 or 50%. We don't have an HSD, we didn't do that, but that's, you've got an AP style statement right there. Make sense? So do you guys think you can do that for IV2 and the interaction? Okay, so let's go through and see what you got for those and see if you got it right. If anybody's stuck and doesn't know how an answer was arrived at, now that we've done one, let me know. Okay, so for IV2, what's the DF numerator? 2. Okay. For IV2, what's the DF denominator? 24. It's the same thing, right? What's the F critical? 3.40. What's the F observed? 8. What's the eta squared? 40% or 0.4. And if we did the APA style statistical statement, I can write that up here for the next one. It's going to be F2, 24, 8, P is less than 0.05, eta squared equals 0.4 or 40%. Okay? Okay. All right, now for the interaction. What is the degrees of freedom numerator? 2. The degrees of freedom denominator?
24.
Yep. F critical?
3.40.
3.4. The F observed? 6. And eta squared? 0.33 or 33%. Okay, and if I do the APA style statistical statement, it's going to be F 224 6, right? P is less than 0.05. Eta squared equals 0.33 or 33%. See, not so bad. You got this. All right. What next? 5. All right, Abby has been patiently waiting for number 5. Okay. So this is a very visual one, so you can have a picture of it. All right. Whoa. That one, right? Okay, so here's some results. You've got a bar graph on one side and a line graph on the other side. Okay. So, what you have to do is look at the graph and say whether you think the graph suggests that there's a main effect of each IV and or an interaction of the two IVs. And you have to explain what information you use to make the decision. And it needs to be graph appropriate. So for example, I've had people do this on tests before, where I give them this graph, and they say, oh, well if you drew a line from the top of the black lines to the top of the white lines, the lines would intersect, so there's an interaction. And I'm like, I didn't ask you to tell me how to tell if there's an interaction in a line graph. I asked you to tell me how to tell if there's an interaction in a bar graph. Don't draw lines across the top of the bars. Tell me about the bars. So, do you think there's a main effect of phototype? And how would you know? What kind of information do you use to decide if there's a main effect of the variable on the x-axis in a bar graph? What are we comparing? Well, we're not doing direction or distance yet. What we're looking at is, if I'm looking at phototype and I want to figure out if there's a main effect of phototype, what two groups of subjects am I comparing? The subjects who experience what and the subjects who experience what? The subjects who saw the alcohol-related photos and the subjects who saw the plant-related photos, right? If I want to figure out if there's a main effect of phototype, right? I want to know if there's a difference between the scores for people who saw alcohol photos and the scores for people who saw plant photos. Well, how do I tell? What do I look at? I'm comparing what bars to what bars?
Combined alcohol and combined plant. The combined plant and the combined...
So we're looking at the combined alcohol bars compared to the combined plant bars. So if we compare the combined alcohol bars to the combined plant bars, what do you think?
They're not the same.
They're not exactly the same. Are they super different?
Really, like, maybe a substantial difference.
Maybe not a substantial difference, so maybe a main effect? Could be. They're not super different, but there could be, because it looks like, this one is a little taller. Here the white bar's a little bit taller, but here the white bar's a little bit taller, right? So I don't know, if you average them together, if we average these two together and average those two together, my gut instinct is maybe not, because I just don't think they're that different. Because if I blend these two bars together and these two bars together, and compare the two blends, I doubt they're really that different. And what about the line graph? What data do I use to say if there's a main effect of phototype on the line graph? The slope. Okay? Well, I've got two slopes. One's going like that, and one's going like that. That's a crossover. So they cancel each other out. So if I look at the line graph, it really seems like, yeah, probably not. Because these slopes are basically perpendicular to each other. Almost. Not quite, but pretty close. So those slopes are probably pretty close to canceling each other out, which suggests that there's no main effect of the variable on the x-axis. Now, these are for the same data, so your answers should be consistent with each other. Don't go, there's definitely a main effect here, but there's not one over here. That makes no sense. The cues should give you the same information. All right, now what about a main effect of word type, which is the variable in the legend? What cue would we use? We're comparing aggression-related words and neutral words.
Could be the combined aggression.
Right, the combined aggression bars and the combined neutral bars. So if I look at the combined black bars and compare it to the combined white bars, what do you think? The combined black bars, the average of the black bars compared to the average of the white bars.
Not much of a difference.
The white bars are taller, a little bit taller, might be, maybe, because if the white bars are taller, could be a main effect, but it's not super, man, I don't have the feeling like, yeah, for sure, but it's like, yeah, maybe, because the average of the white bars is probably a little bit more than the average of the black bars, so maybe, but I have to see the math. It's possible, but, and what about over here? What do I use if I'm trying to figure out if there's an effect of the variable in the legend when I'm talking about a line graph? The distance between them. Okay? Now think about this. How far apart are they?
They're touching.
Yeah, they're kind of apart and then together and then apart and then together. So what distance are we talking about? Right? Because they actually lay right on top of each other here, so they're actually not far apart at all. These are right on top of each other. And this one's high up here and low down here, but this one's high up here and low down here. So, this looks like no main effect here either. Now, what about the interaction? You think there's an interaction in this graph? And why do you think so?
The difference and the direction don't match.
The difference and the direction don't match. So if we look at what's over here on the left, we see black is this much shorter than white. And over here, it's white is this much shorter than black. So the direction, the one that's taller changes, and the difference between them also changes. And that says interaction. Neither the difference nor the direction are the same for the two pairs of bars. On the left, the white bar is substantially taller, and on the right, the black bar is substantially taller. So the difference and the direction have changed. And in a bar graph, that's what you need. You need to have, in order for there to be no interaction, you have to have the same difference, same direction, right? But if one of those, if the difference has changed, or the direction has changed, or both, then you're talking an interaction. What tells you over here that there's an interaction? Because they cross over. This is a perfect crossover. This is a crossover interaction, right? The lines clearly intersect in the middle of the graph. Now, when you're describing things like this on the test, make sure you're very clear about what comparisons you're making. So if you say, if I ask you, tell me about the main effect of phototype for a graph like this, you need to be clear when you say, if I compare the 2 bars for alcohol photo to the 2 bars for plant photo, they look about the same on average. So I think there's no main effect. But don't say, if I ask you, tell me about the main effect for phototype, and you go, well, if I compare those bars to the other bars, then they're the same. That doesn't tell me anything. What bars to what bars? So be specific. Say, if I compare, and don't say like, if I compare the bars on the left to the bars on the right, where these are on the left and those are on the right, right? So be specific. If I compare the black and white bar for the alcohol photo and the black and white bar for the plant photo, and if I average those 2 pairs, right, if I average the alcohol photo bars together and I average the plant photo bars together, I think that the averages are about the same, so I think there's no main effect. Be specific what bars you're talking about. Don't hope that if you're vague enough, I will insert the relevant information. I will say, I can't tell what you're comparing, so I'm going to assume you're wrong. It's not that I don't love you, it's that it's your job to make sure it's clear what you know. All right, so if we look at these graphs, what do you think? Oh my gosh, here we go. Younger and older drivers on the phone, not on the phone. Oh dear. Okay, so if I want to see if there's a main effect of cell phone condition in this graph, what do I do? What do I compare?
Combined on the phone and the combined not on the phone.
So I combine the on the phone bars and compare it to the combined not on the phone bars, and what do I think?
Not much of a difference.
Doesn't look like there's a super bunch of difference. There could be the not on the phone bars are shorter. Maybe, but it's definitely not a very persuasive effect if it is one. What would I do over here? If I wanted to figure out if there's a main effect of what's on the x-axis.
The slope.
I would do the slope. Okay, well let's look at the slopes. Are they super different? Or is it super steep?
Not really.
I mean, they're not totally parallel, but it's not a super steep slope, is it? They're pretty close to being flat. I mean, maybe, again, could be, because the slope isn't totally zero, but they're not like that either, right? So,
You have to take into account like the scale of the y-axis and like the context of the experiment to see if it's like a significant main effect. Because if the scale is like, I don't know, really large, and like even if there was like 4 seconds of difference, but you have a really big scale, like the slope would still look
flat, pretty steep.
right?
Yeah, it would still look pretty flat.
So
I mean, just describe to me what you see the way I presented to you.
okay.
So, I have tried to, I mean, these are data from the study that they talk about in your book, right? These graphs are all from the studies talked about in the textbook. So, those aren't, I mean, it's not totally flat, but it's not super, I mean, it's not like really steep either.
Yeah.
So, there does appear to be a slight slope, suggesting that there may be a possibly small main effect, but it's not, I mean, maybe. You want to describe this now in very soft terms. Because I mean, there is a slight slope, so it could be that there is a main effect, but it's not very convincing, right? I mean, if you do the math, you'll find out, but I'm not giving you the math. I'm just making you look at the graph and tell me. And sometimes when you look at the graph, you're going, well, maybe. Sometimes that's the answer, because it's not super convincing. But you have to tell me why maybe. Because the slope of the lines is not very steep. They're not flat, but it's not a very steep slope either, so maybe. All data isn't beautiful, like, oh look, all lines have slopes like this. It doesn't look like that. Okay, what about the main effect of what's up here on the legend for the bar graph? What am I comparing?
Combine young drivers to combine older drivers.
Okay, I'm comparing the combined bars for the younger drivers to the combined bars for the older drivers. And what do you think? Doesn't seem like there's very much of a difference. So again, if you say it doesn't seem like there's very much of a difference between the combined younger driver bars and the combined older driver bars, then your conclusion should be, so there's probably not a main effect. But if you say, it looks like there's a difference between the average of the younger bars and the average of the older bars, so I think there's a main effect. So your wording, what I'm asking you to do is make a judgment and back it up, right? Make a claim and then give me your evidence. We're practicing for the paper writing stuff that's coming next week, where you're going to have to start making claims and backing them up with evidence. And I may agree with you or may not agree with you, but what I'm asking you to do here is make a claim and back it up. And if you can back it up, and I can look at the graph and go, yeah, okay, I can see that. I mean, if they're clearly exactly the same, then don't say, there just could be a small difference of, a fraction of a millimeter. I'll just be like, seriously? Where? Really? But here, I mean, I can look at that and see if there's a little bit of a difference. They're not exactly the same, so I'm okay with that. What I want you to do is make a claim, back it up with evidence. What about over here? How do I tell if there's a main effect over on the line graph of that variable in the legend? The distance of what?
The lines.
How far apart the lines are from each other, right? How far apart are they from each other? Not super far apart. They're a little bit far apart. They're not exactly right on top of each other. So again, you could say, well, there is some distance between them, but it's not a really big distance looking at the scale. So not so much. Or you could say, the lines are not right on top of each other. There is a small difference between them, so I would say there may be a small main effect. Make a claim, back it up. What about interaction? Do you think there's an interaction over here in the bar graph, and why do you think so? Interaction is difference and direction, right? Okay, so the difference here, right, about not even a finger width of black shorter than white. If I come back over here, black shorter than white. Is it the same difference, same direction?
Just about.
Pretty much. Hardly any difference at all. So I would be hard pressed. I think it's probably unlikely you've got any big main effects going on, any big interaction going on. Maybe, could be. Look over here. Does this look like a really big interaction? That's a line graph for the same data. I mean, they're not totally parallel, but are they zooming towards each other at an incredible rate? Not really.
I mean, if the lines went on forever,
Eventually they would run into each other. But if there is an interaction here, it's going to be a pretty small, pretty weak one. Because those lines look pretty close to parallel to me. They certainly don't look like those lines. Right? That really looks like it. If you get this graph and there you say, well, it's possible there could be an interaction, I'm going to jump up and, no, I'm not going to do anything. I'm just going to go, excuse me, what? You think there might be an interaction? Here, your wording should be, yes, there's definitely an interaction. Those lines are intersecting in the middle of the graph. There's no question. Here, there's a change in difference and direction. There's definitely an interaction. But that's a different claim, a different strength, and different evidence than little tiny difference, little tiny confidence in my... Yes?
So can I say the lines are not totally parallel,
Mhm.
so I conclude that there is a weak interaction.
There could be a weak interaction. Yeah, sure. Because what I'm looking to see is, if you make a claim, what evidence are you using to back it up? And now you see, I mean, lots of people just like to look at pictures, but in the absence of the math, you don't know for sure that's why we do the math. Math is good. Math lets you say conclusively, I did the math, and here's what the math says. The math says, yes, there was a significant effect, and it was this big. But we don't know in the absence of math. All right? Other things. We still have 15 minutes. What else do you want me to talk about for 15 minutes? We want to go over either one of the experiments in 4, 3, 4. Okay? Which one do you want to do? A or B? Huh? B? All right, we'll go for B. The squeaky wheel gets the grease. You wanted to do it, you should have been louder. All right. Loud is good. Hey! Be confident. By now you should know I'm not going to bite your head off or something. So, okay. So it says, a researcher interested in maze learning hypothesizes that maze learning can be influenced by the size of the reinforcer and by the delay in the reinforcement. Animals are given 40 learning trials in a maze, and the number of errors per trial is recorded. There are 6 conditions. The reinforcer is a food pellet that's either 10 milligrams or 20 milligrams. The reward is given at 1 of 3 times after the animals complete each of their respective trials. 0 seconds, 10 seconds, or 20 seconds. The delay is always the same after every trial for a given animal. The average number of errors made by the animals trying to complete the maze in each condition is provided below. Assume a critical difference for all comparisons of 12 errors. Okay. Okay. This is delay. 0 seconds, 10 seconds, 20 seconds. And this is size. This is 10 milligrams. Okay. How do I figure out if there's a main effect of size? What do I do?
Add those backwards.
We've got to add an average for main effects, right? So what am I adding? What am I going to add? I need to know, if I'm comparing size, what I need to know is there a difference between 10 milligrams and 20 milligrams, right? So I'm going to treat all the 10 milligrams like they're the same and all the 20 milligrams like they're the same, right? So for 10 milligrams, I'm going to add it up. I'm going to take 5 plus 35 plus 40. Add that up, what do I get? What's 5 plus 35 plus 40?
80.
80. Good, thank you. And then I have to, that's the adding part, and then I have to take the average. So I'm going to take the average, 80 divided by 3 is what? Huh? 26.67? I don't do math, remember you guys do math. You got that too? All right, we got a confirmation there. 26.67. Okay. So that's the average for 10 milligrams. For 20 milligrams, I'm going to take 10 plus 40 plus 45. What's that equal? 95? I don't know. I don't do math. You guys do math.
95.
95. Okay. When you get a PhD, you don't have to do the math anymore. Yeah.
You got
Oh, on the chart. Apparently people with PhDs don't read either. Okay, so this is 5, oh, that's 25.
No, he did respond back. Like he was like,
So then
I
this
thought we
is
were supposed to.
right? Is that right? Okay,
Right.
fixed.
Like, this guy-
Okay, so then we take 95 and divide it by 3.
31.7.
31, see now I got people doing it, I got my chorus going. You guys just forgot how to do this part because we didn't do it in math this time. All right, so I'm comparing, now I've added, I've averaged, now I'm going to compare, right? Now I'm going to compare 20 milligrams and 10 milligrams. Okay, I'm going to compare them. So what am I comparing? I'm comparing 26.67 versus 31.67. How different are those two things?
5.
5, thank you. Confidence of 5. All right, so those are 5 different. All right. Now, what did it say up in this little summary? It said, assume a critical difference for all comparisons of 12 errors. These are different by an average of 5 errors. So is that a significant difference? No. That means there is no main effect of size. In other words, size does not matter.
Well.
That's what it says.
We're talking about
I'm talking about rewards for rats running mazes. What are you talking about? Don't worry about you guys. Here, I was all proud of you because you're wearing a Denver Broncos hat. And I'm like, go Denver. I'm from Colorado, so go Denver. Size does not matter. That's what that says. Mine, you're going. What do you think I'm talking about? Okay. Next one. All right, so now we're going to do delay, right? See if there's a main effect of delay. See if I can label them correctly this time. So this is 20 milligrams and 10 milligrams and 0 seconds and 10 seconds and 20 seconds, right?
Can you move it down a little bit?
Yeah, sure. I will. Yep. So now I'm doing delay, right? So now all I really care about, I don't even really care about this part. All I care about is these ones, right? Because those are the different categories of delay. All right, so we've got 5, 35, 40, and 10, 40, and 45. Okay, so for 0 seconds, I'm going to do 5 plus 10, and that equals 15. And then I'm going to take the average. Last time I divided by 3. Should I divide by 3 again? No, divide by 2. And I am not kidding. Every single semester I have somebody who does the averages, and whatever the first one was, they just keep dividing by that amount for the whole rest of the problem. So if the first one was 2, they'll average, they'll go, oh, 15 divided by 2, okay. And then when they get to the one that has 3 levels, they keep dividing by 2. It's like, no, you always, it's average, right? So you divide by the number of conditions for that variable. So always double check it. Okay, so that's 7.5. I can do that in my head. Okay. Let's see, next one is 10 seconds. 35 plus 40 is 75. 75 divided by 2 is what?
37.5.
37.5. Okay? And then we have 20 seconds. Okay, I'm going to add 40 plus 45. What's that equal?
85.
85. Yes. 85 divided by 2 is what? 42.5. Okay, so now I'm going to compare. 7.5 versus 37.5 versus 42.5. I'm comparing. All right. So, how different are these two from each other? 30. How different are these two from each other? 5. How different is 7.5 and 42.5 from each other?
35.
Between 7.5 and 42.5, they're 35?
Oh, yes, 35.
35. Okay. Are any of those differences bigger than 12? Yes. Okay. This one's bigger than 12, and this one's bigger than 12. So what does that mean? It means we have a main effect of delay. Okay, we have a main effect of delay, and what's the main effect of delay? What's the effect? This is 0 seconds, this is 10 seconds, and this is 20 seconds. So what's the effect? What's happening? Which one is different from everything? 0 seconds is different than 10 seconds, and 0 seconds is different from 20 seconds. Okay? So there's a main effect of delay such that what? Such that rats who were rewarded immediately upon exiting the maze made significantly fewer errors than those who were rewarded after 10 seconds or 20 seconds. Right? Is that what happened? I think so. So if you had got that main effect, you would have to say all that stuff. It's just like doing it for a one-way ANOVA. Because this is basically just a one-way ANOVA, like you did a little Tukey test right there, and now you're telling me what happened. Main effective delay such that, there is a main effective delay such that rats who were rewarded immediately upon exiting the maze made significantly fewer errors than those who were rewarded after 10 seconds or 20 seconds. All right. What's left?